So we are saying tutorial sheet probability. Okay, so go straight to question 1, then I'll be getting so much concept from the questions. They will remind me of my notes, then I can even leave the test and go to my notes if I remember them as we do this. Question 1, if A and B are events such that, so if A and B are events such that the probability of A is half, the probability of B is 1/3, and the probability of A union B is 2/3. Then what should we find? Find, this is A, find 1, the probability of A intersection B, and then conditional probability, the probability of A given B. Okay, so first we talk about the probabilities of A intersection B, A union B, probability of A, probability of B, and what the probability is actually. The probability is a chance theory. You're looking at the possibilities of something happening. So that's what we should have in our mind. So, like, for the guys who like betting, what's the probability that this team you want to put money for is going to win? Okay. About your career pathways, what's the probability that you're going to make it? What's the probability that you're going to clear all the courses? What's the probability that if you're coming from home, tomorrow is going to rain and you miss classes? So those are possibilities of things that can happen around. So just thinking, and then we call it probability as in math. And then the probability formulas now, the probability of A union B is the probability of A plus the probability of B. Now look at this. This is A, this is A, this is B. The probability of A, you're talking about the whole A. Probability A. And then plus the probability of B. You're talking about the probability of B. In probability, you must never repeat the addition of one thing. You can't add something twice. Now, if you can check very well there, the intersection has been added twice. When you say probability of A, you get everything in A, including what is in B. You got probability of B, you get everything in B, including what is in A. So, to avoid that addition, in the formula of probability of A union B, you would subtract the probability of A intersection. You subtract it once, meaning it will be added once. So this A to add it, and then you add it in B because you have subtracted. So add it in B first, and then subtract it once because you added it twice. For that matter, since we're looking for the probability of A intersection B here, which is here, so you can take it the other side and take this guy the other side. So we're going to have the probability of A intersection B will be the probability of A plus the probability of B minus the probability of A union B. So even all probabilities there, the probability of A is 1/2 Probability of B is 1/3 minus 2/3. So you have the common denominator 6, and then 2 into 6 goes 3 times. 3 by 1, you get 3, plus 3 into 6 goes twice. 2 by 1, you get 2, minus 3 into 6, 2. 2 by 2, you get 4. So we have 5 minus 4/6, 1/6. The probability of A.
Sir, I have a question.
Okay.
I'm kindly asking if you can repeat on the part where we included the minus probability of A intersection B.
Okay. So that part is actually coming from here. So I will do my sets. This is set A, and you get a probability of A. Probability of A. Plus, you bring it, and you get the probability of B. Okay. Let's do it in color. Like this. Then they say find probability of A union B. If these guys were like this, they do not intersect anywhere. The probability here would have been probability of A plus probability of B. So you're adding the probabilities of the terms of A and the terms of B. Now, should we have that B moved A? Should B be moved to A with its elements? Then you find that some of them are also in A. Okay. As B is coming, B would have found you've already gotten the probability of A elements. Then, wherever B is sitting, you also get the probability of B elements. Then now what happens? So it means that you have this piece here that we have added twice. It was added in A, it was added in B. So subtract it once. A intersection B. We'll subtract it once because we added it twice and don't want to do any re-addition. That's the reason why the formula comes out to be this way.
All right, sir.
Okay. Now you can see that should we be told something about A and B in terms of them being disjoint? When you say two sets are disjoint, what do we mean? So if A and B are disjoint, meaning A intersection B is empty, then the probability of A union the probability of B is going to be the probability of A plus the probability of B. I think I did demonstrate that if you have this structure here, this is a universal, and then I have A here, I have B here. Then you get this probability plus you get this probability. So there's nothing that you are saying has been added twice. So you just add them and then you're okay. Okay, then we now look at part B of our,
Yes. What about in terms of when it's a subset? Say A is a subset of B.
A is a subset of B. And you want to get a probability of A union B. You get the probability of B. Because A is in B. Because by then, if A is in B, then you have this structure. This is B, and this is A. So the probability of A union B is the probability of A plus the probability of B minus the probability of A intersection B. But this is the probability of A plus the probability of B minus what is A intersection B? A intersection B is A. So minus the probability of A. So this guy and that guy. So you have the probability of B.
Thank you.
Okay. Okay, so go back to our question. We look at, or before I go back to our question, what if they ask us to find the probability? Since now we know the probability of A, the probability of A is half. What if they say, find the probability of A complement? What do you do? One thing we must know is that the total probability is 1. Okay. And the smallest is 0. So we also know that A union its complement is actually the whole universal set. So the probability of the universal set is 1. This means that if they ask us to find, the good part of A union B, A union A complement, their probability is the probability of A plus the probability of B. Oh, as the probability of A complement, I mean. This is because A and A complement are disjoint. They do not have any intersection. The intersection is empty. There's no term that can be found in A and outside A at the same time. So if you want to get the probability of A complement, you get probability of A complement is equal to the probability of A union A complement minus the probability of A. But this is the total probability, so you say the probability 1 minus probability of A. So you have 1 minus half, which is equal to half. Okay, now I go back to the question. What is the probability? That is part 2. What is the probability of A given B? So this is going to be the probability of A intersection B over the probability of A. No, over the probability of B, not A, over the probability of B, the one that is given. This is the formula now for a condition. So here I was saying that you'll be given the probability of B. Now you're looking at the probability of A. That depends on B. So what is the probability of A? Given that probability of B has been given already. You will see this when you do some tree diagram questions. That's when you're going to appreciate the extension of the probabilities. So we found A intersection B. We said probability A intersection B is 1/6. So here is just placement 1/6 divided by probability of B. I think we wrote it is 1/3. So we have 1/6, 3 or 1. So 3 there, 1, 3, 2. So it's 1 or 2. Okay. Then next, what is the probability? The probability of B complement A. So when you say B, you go and get the probability of A intersection B complement over the probability of A. So what's the probability of B complement then? So we need the probability of B complement. So look at this. If this is A, this is B, A, B, and you have this. The probability of B complement is the outside of B. The probability of A is B complement. But we can get it from here. From here, probability of A intersection B complement is equal to the probability of A. So get the probability of A, and then minus the probability of A intersection B. To come and move the intersection that we remain with. We remain with this on. Okay. So by subtraction, then we remain the probability which is the intersection. So now we know that okay, half the intersection is 6 down. So have 3 minus 1. This 1 is 2 over 6. So the intersection is 1/3. So you take it there, 1/3 divided by 1/2. This is 1/3 and 1 is 2/3. Okay. Any question? Two. So two, we are saying that these guys are given as just formulas, even in this course. And if you ask to find the probability of A given B, we just get the intersection of A and B and obtain their probability and then divide by the probability of B. Then you extend this definition to 3. And for 3, you open the numerator. How is I got your question. How is A turning into the How is A turning into intersection? A has turned into A intersection B. A is given to work as a bit of A intersection B over B. Okay. So there was much in this course. Rules are taken is we're able to tell you how the probability of A are given B gets to this probability of A intersection B over the probability of B. The corresponding probability. Okay. The probability of A it depends on B. So question of how that formula come about. Well, that answer in this course. That is the second year course. First, we was we do like we have a bit of intersection. What we do is A minus a bit of B. The total correct. Like now we have a bit of intersection, we would part of B. Is that what is everything that is the outside. The order, okay. something else. This is M B. We take a B. A is number 2, B is 1 of them. 2 here 3, here 2, 1 of 6. So need true if A and B are not right. But when you subtract B, there's nothing even this. I am going with A. That's why this is open. Thank you. Okay, let's look at the next concept. If evidence B, an event in B, one event. Two events are said to be independent if probability of A intersection B is probability of A divided by probability of B. The two probabilities, the probability of A intersection B, I mean, said A and B, which are in this case, are said to be independent if the probability of intersection is not probability. Product of probability. So let's check. We found A intersection B. Let's find out. Okay, let's check. The probability of A intersection B will go on over. The probability of B, it was 1 or 2 multiplied by 2 over 3. Giving us 9 probability of intersection goes 1 over. Of intersection is 1 hours. So then we know also here we have half divided by 2 already, which is 1. Yeah. And on the left, the value of A is in B, 1 over 6. So we are saying events A and B are said to be independent events if probability A into B equal to probability A for B. So, I understand the question I was going on. The having the possibility that A open is affected by the probability. The two okay. Oh, my sorry, my sorry, okay. So don't now A independent since the bit of A the probability is equal to A.